Today we're going to talk about section 2.4, which is polynomial functions. We've actually been kind of talking about this in the past few sections, but we're going to generalize what we've been talking about. We've talked about specifically linear functions and quadratic functions, which are types of polynomials, but now we're just going to set up a more general example. We know that we write functions with this function notation, f of x, where this is our independent variable. That's the one we're going to plug into the equation. And we have then a mathematical equation that uses this independent variable. Well, a polynomial function looks kind of like this. This is an example of one. And we have several different kinds. These are all polynomials. A polynomial has what's called a degree, and we can look at these exponents, and that can give us some information. Like this is a degree of 3 because that's the highest exponent. This is a degree of 0 because remember, anything to the 0 power is 1, so there's no x there, so x to the 0 power. And this one has 11. So we'll talk a little more specifically about this stuff in a few minutes, but these are some examples of polynomial. So in general, when we write general equations, we use lots and lots of letters instead of the numbers so that we know that we're not being very specific. So for a polynomial, sometimes we use p of x. It doesn't really matter what letter you use. But what we have is we have these terms that look like this. And what this means is we've got some number here, an, times x to whatever variable, and then to the next one down, and we've got some number in front of it, and it's x to the next one down, and then to the next one down. And we just keep going until we get ourselves all the way down to, and we're not going to write the x to the 0 power because anything to the 0 power is 1, so we don't need that. And all these numbers in front, these a, n, these a sub n minus 1, a sub n minus 2, all the way down, a sub 2, a sub 1, a sub 0. These are all real numbers. That means is contained in a set of real numbers. And the first one is not equal to 0. Now, all these little exponent things up here, all the n's, have to be positive integers. The way you write that, this means integers, and we put the plus sign there, that means positive. So n is a positive integer. If we have like x to the 1/2 power, that's not a polynomial. It has to be like x cubed or x to the 5th or something like that. So the powers up here have to be positive integers. N is called the degree, which we just saw some examples of that. The degree of the polynomial, that's the highest exponent. You can't have any weird things in a polynomial like sine or logs or things like that. You wouldn't have any square roots. Usually we write our powers in descending order like we've got it here. Like this could be 5, 4, 3, 2, 1, 0. Usually you write it that way. It doesn't matter. It just is easier if you go ahead and put it that way. But that's a polynomial. They're kind of the basic function that we work with. There's all kinds of different functions in math, but polynomials are a basic one that we deal with a lot because there's a lot of different ways to do it. Now let's try an example. If we have a polynomial that looks like this, so 8x to the 4th plus 7x cubed minus 5x squared plus 16x minus 11. if we have that, and one of the things we'll often do is we'll evaluate polynomials at certain points. So the way we write that is we have our number we're going to plug in. What that means is we're going to plug in everywhere we have an x. We're going to plug in this number instead. And this is giving us a specific value for this polynomial at this specific x value. And if you plug all this in, make sure you do your exponents first, then your multiplication. Remember those order of operations, parentheses, exponents, then multiplication and division, then addition and subtraction, and you get 355. Now, you can do this on your calculator. I'm just going to give you a kind of a brief overview with that, and and then I'll show you it in class. So on your calculator, if you go to the graph menu and you set this polynomial in as y1, then on your main menu or on your home screen, you can type in y1 of -3 and then hit equals, and it'll give you your answer. So that's just an easy thing. We'll look at that. Hopefully we'll have time to look at that in class and be able to watch that on the screen in class. Now, sometimes with polynomials, like for example, we've done a problem like this before, where we had to add or subtract polynomials. So let's say we're given that p of x is 12x cubed plus 11x squared minus 9x plus 10, and q of x is equal to 4x squared minus 3x plus 2. So those are two different polynomials, examples of them. So we can add, subtract, multiply, or divide polynomials any way that we need to. For example, if we want to add these together, then what we do is we look at this and we say, okay, you can only add like terms. Remember, apples with apples, oranges with oranges. So only things that are alike can be added together. So this is an x cubed term. So there's no x cubed term over here. So when we add the two together, we still just have the 12x cubed. Now, the x squared term, we've got 11x squared here and 4x squared here. So how many x squared terms do we have? Well, if you add those together, we've got 15. Now, excuse me, with the x term, we've got -9 here and -3 here. So when we add those together, we have -12x. And for the plain number, we've got 10 here and 2 there, so plus 12. So that's how we add them together. Hopefully that's review. Hopefully you know how to do that. You can multiply, you can subtract, you can divide. Let's do a division one. Well, with division, what you have to do is you set it up, or to do long division at least, you set it up by putting the thing in the first one, what you're dividing, inside the little division house. And then what you're dividing it by, you put it out front. Now, you look at your first terms. What do I have to multiply 4x squared by to get 12x cubed? Well, 4 times 3 is 12, and x squared times x is going to give me x cubed. So I've got my 3x is what I'm going to do. So then I multiply that times all of this. So I've got 3x times 4x squared is going to give me 12x cubed. And then 3x times -3x is minus 9x squared. And then 3x times 2 is plus 6x. And then just like with regular division with numbers, we subtract all that, which means all these signs are going to change. And of course, those are going to cancel. That's what we were trying to get. and we get 20x squared minus 15x, and then bring down the plus 10. So it's just like with regular numbers. We just have to have some variables in there. So now, what do we multiply 4x squared by to get 20x squared? Well, 4 times 5 is 20. So we got to put plus 5. Make sure you put that sign in there. And then we multiply it out. So we've got 20x squared minus 15x plus 10. And we subtract that. And in this case, this means we have no remainder. All right, so our answer is just 3x plus 5. Hopefully we remember that from Algebra 2. Now, like I said, there's lots of things we can do with polynomials. We can add them, we can subtract them, we can multiply, we can divide, we can plug in numbers to find values, we can graph them, we can find zeros of them. Now remember, finding a zero of something is when that function, where that function equals 0, where it crosses the x-axis on the picture. So if we have a graph that looks like this, then this is a 0, and this is a 0, and this is a 0, because that's where it crosses the x-axis. It's where x is that y. So in these cases, y equals 0. So it's where the function value, which is y on our graph, equals 0. So that's what we're looking for when we're looking for zeros. So if we want to find the 0, say we have a polynomial 6x squared plus 8x minus 30. If we want to find the zeros for this function, we know it's going to look like a parabola because it's a quadratic. So when we find the zeros for this function, we are finding the two places where it crosses the axis. Another name for these are roots. So it's zeros or roots is what they're called. And you always have, whatever the degree of the polynomial is, that's how many roots you have. Now, that means in this case we're going to have 2. Now we know that sometimes a parabola doesn't touch the x-axis at all, so how can we have 2 zeros or 2 roots then? Well, that means they're imaginary. So sometimes we have imaginary numbers we have to deal with, but there's always the number of roots is equal to the degree. So this is a degree of 2. It's a quadratic because 2 is the highest. That means there's going to be 2 answers. Now, when you have a quadratic, we've already looked at this, you have some options. When you're finding zeros, we've established that you can find them by factoring. You can find them by completing the square. And you can find them by the quadratic formula. Now, you can also find them using the graph on the calculator. Your calculator can compute zeros for you. We're not going to really use those with the quadratic, but this will work for all polynomials as well. So, well, let's look at this and first decide, well, can we factor it? Well, let's see if we can factor out just a number to start with and see if that'll help us see what happens. These are all divisible by 2, so if we factor out the 2, then we have 3x squared plus 4x minus 15. So then we have to say, well, does this factor? Hopefully you're pretty proficient at factoring at this point. You really need to be. If you're having trouble with factoring still, you need to practice, 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 practice. That's the best way to do it. So it does factor. It factors into, we know that 3x squared just is 3x and x. And the only way to do 15 is 5 and 3 and 15 and 1. But we know we have to have opposite signs. So if we put in opposite signs, then we can kind of experiment. Well, if I put a 3 here and a 5 here, then I'm going to get 15 minus 3, which is 12 in the middle. Well, that's not what I want. What if I put 5 here and 3 here? Well, then I have 9 minus 5, which is plus 4 for the middle, which is what I want. Now, when you're multiplying two things together and you know that their product is 0, you know one of them has to be 0. So the two answers are when these things are equal to 0. So we solve those, and we have x is 5/3 or x is -3. Those are the two zeros. 5/3, 0 is a point where the graph hits the x-axis, and -3, 0 is a point where it hits the x-axis. Okay, so a 0 is when the equation is equal to 0, which happens to be where it crosses the x-axis. Now, we know how to do it with quadratics, but if we have higher degree polynomials, we're going to work on factoring those in the next section, and we'll see some ways that we can help ourselves out to make that easier. So read over the section, take some notes, review some stuff, make sure you know how to factor and how to deal with that. If you have any questions, write them down and bring them to class next class period.